All right, welcome everybody. So here we have another issue of the PBA podcast. And today we have the team from Ideal Labs. My name is William, and I am a representative of the PBA. I'm a former PBA 4 graduate, and so are the other guests here today. Tony, I'm going to hand it over to you. Please take it away and introduce us to Ideal Labs and the team that you have here.
And thank you, William. Hey, everybody, I'm Tony from Ideal Labs. So we are a team working together since we all met at PBA 2 in Buenos Aires. Ever since then, we've been working together to build verifiable randomness solutions, which we're really excited to start bringing to people soon. So a little bit about myself. My background is in mathematics and software engineering, of course. We kind of all started discussing things like secret sharing and how do we share a secret on the blockchain, things like that at PBA, and that really got us thinking about what's not there in the ecosystem, and what how do you actually do something that accomplishes something like that without a trusted intermediary, that essentially led us to where we are now, which was a really interesting journey.
And Carlos and Juan, please introduce
Yeah,
yourselves.
yeah, definitely. Let me take over. Well, I first met my co-founders during the PBA, as Tony said, and since then we have been uh, with this idea of contributing to the decentralized journey, particularly with Web3. And my background is in software engineering. I have 20 years of experience. I started my career doing custom software development for the energy industry, but then quickly transitioned to the startup world. I have started 3 companies myself. One of them was acquired. The second one is still a business, and this is the third one, and hopefully the biggest one. And the reason,
The last one.
hopefully the last one. No, I guess that the last one is not the right way to say it, but definitely, I hope that this be a really fascinating journey, and along my co-founders, which I'm fortunate to be partnered with them. So yeah, that's how we met and how we started. I'm going to pass to Juan so he can say himself.
Hey there. My name is Juan. I've been a software engineer for the past 20 years or so, and I've been involved in the Web3 space the past 3. And within Polkadot since PBA 2, that was like 2 years ago, something like that, where we met and we started this Ideal Labs journey. I'm also a former Parity core engineer, and now in these exciting times for trying to deploy our own Parity Polkadot.
Great. And I guess there's something that I have to ask. Maybe everyone is wondering, but how did you guys all meet? I mean, I imagine you all met at the PBA class, right? The PBA is people fly in from all over the world to be together to learn about Polkadot. But were you roommates? Did you find yourself together at the lunch table the first day, or how is it that you connected and
Not really.
found a
Yeah,
shared interest?
yeah. I can add a little bit of that, Tony, and you guys, but it's funny because we were on different, of course, different places. I mean, same building, but different places. We didn't know each other. I knew Tony, and we started talking about things. I knew Juan, and we were talking about things. But there's a moment where I recall that we were in the same table talking about these things, and kind of started to feel that team environment, or that like energy of, oh, we should do something together. But that's pretty much from my end. But I don't know how you guys recall it.
Yeah. I remember that Carlos and I were bonding a lot. I guess probably because of language. We both speak Spanish as the main language. So I remember we were talking a lot. Once we went out for a beer, and we started discussing about business ideas, things that we could do with all these amazing things that we were learning. And we started talking about privacy and data encryption and stuff like that. And it was interesting. And one of the last parties at PBA, or maybe the last one, I was on the queue to get some food to eat in this PBA party. And Tony was just, I don't know, maybe in front of me or behind me. And I was sharing this idea that I had with Carlos, with Tony. And Tony said, hey, I have a very similar idea. Why don't we talk more about this? And yeah, this is how it all started.
Yeah, so let's just jump right into kind of the topic of what it is. I think maybe to frame it a little bit, what I find quite interesting is that Ideal Labs is, your product is not just at a single level, right? It's not just a dApp, it's not just a parachain, but you have something kind of at each layer, right? And even you're customizing the parachain a little bit. So give us a quick overview of what Ideal does, what your main product or products are.
Yeah, so I can get started with that. So everything really started with us trying to build a native randomness beacon, a substrate native randomness beacon that's more efficient, more optimized than what DRAM can. So that's essentially what we built up through our participation in the decentralized futures program. We built that out as a press finality gadget. The problem was we didn't build out a mechanism to actually deliver that across parachains and make it usable. So what we're really doing with this, proposal that we're doing now is, rather than delivering our native randomness beacon, which we use a different type of way to verify it, we are essentially bridging DRAM. We're bringing DRAM's randomness into the Polkadot ecosystem to try to focus more on the dispatching randomness and making it available across chains rather than just producing it ourselves. Carlos,
And yeah, please go on, Carlos.
Yeah, definitely. I can complement that. I think that the interesting part of our product is we want to deliver value as soon as possible to the Polkadot ecosystem, because we know that randomness, verifiable randomness in particular, will be very valuable for a lot of things. But also we have this ambition that our infrastructure piece, which is, as you say, the journey we decided to take, instead of going to a debug, we went to this rabbit hole of building infrastructure, and it's hard, but it's very interesting. We have this idea that we can untap a lot of incredible features as we iterate. So in phase one, which is what we are currently focused on, after having the two previous grants that Tony just mentioned, in phase one, we are kind of consolidating everything that we built so far, and we are building something that is very pragmatic but usable, which is, let's use XCM, let's use the Polkadot capabilities, and let's take advantage of DRAM as a randomness beacon, and let's make it possible to a lot of things to consume this. And then down the road, on phase two, what we want is to expand to other ecosystems and to take randomness to, for example, EVM ecosystems or others. Initially, EVM is our target. And the reason is that part of what we are excited about is that current solutions in the whole Web3 space are either very expensive or with high latency. So it gives us the room to create something that is very unique, which is a high frequency, low latency randomness that teams can just consume via subscriptions in the way that they prefer based on their needs. And that kind of make us excited about our journey so far.
So I guess one of the reasons that you're, let's say, in the news for the Polkadot ecosystem, I mean, you have a proposal up, is that, Parity, I mean, Polkadot is releasing a large smart contract ecosystem later this year. And so one of the important, I guess, maybe if primitive is the right word, is that, we need to have some randomness available for smart contracts to use. Can you talk a little bit about why it's necessary to have randomness in a smart contract ecosystem, and also why is it necessary to import it from somewhere else?
Yeah, so hopefully my microphone is a little better now. Yeah, I can. Is it?
Go ahead.
No.
No,
You want,
your mic is not great.
you take it more.
Juan, take this
Okay,
one.
yeah.
Take
Okay, I
this
can
one.
take this one. So randomness in the physical world is given for granted, right? You throw a die and you get a random value. In computers, it's not like that. Specifically in blockchain, it's not like that. It's a lot harder to produce randomness, and especially randomness that is of quality and that is not biased, and it's difficult to predict, or impossible to predict. So this is not it's not an easy thing to do. And why it's important in contracts? It's actually important everywhere. We have randomness everywhere. Like in consensus systems, we use randomness to select validators. In Polkadot, we have BRF doing that. In games, you need randomness. In NFT production, you need randomness. So there are use cases everywhere, actually. There are some use cases which are more critical and some others which are less critical. In DeFi protocols, it's probably a very critical use case where you need a good quality randomness, and consensus is probably a critical use case. Maybe in gaming, it's not that much. Depends if there is money on stake. So by providing a high frequency randomness at a very low price, we are opening the door to a lot of new use cases which are unfeasible at the moment, that wouldn't be economically possible at the moment. So the idea is that with this, we would not only serve current use case to have a lower price or lower costs, but rather opening the door for new use cases that we haven't thought of. One use case that some people might not be aware of, this randomness that we will provide through Ideal Network, is time lock encryption. So it is the ability of encrypt a message that will be automatically decrypted in the future, or actually the keys will be publicly available in the future to decrypt it. This opens up, again, new use cases that at the moment would require more back and forth. Things like sealed bid auctions, or candle auctions, or something very simple as a rock, paper, scissors game, where you need to, at the moment, you would need a commit and reveal scheme. With time lock encryption, you would only need to do that in one transaction. The idea is about possibilities here.
So time lock sounds like a very interesting concept. Do you have a simple explanation to help people understand? Like, for instance, how do you encrypt something to be only available at a certain time? Is it a certain block time? How do you make it so that nobody can actually get the value before that time?
Okay, so now hopefully my audio is a little more clear.
You sound great. Go ahead, Tony.
Yes, so time lock encryption is really identity-based encryption in disguise. So the way it kind of works, and I can send some more technical docs, you can link it in the notes or something. Essentially, the way it works is the randomness beacon itself acts as a signature generator. So each round of this beacon outputs a signature. The hash of that signature becomes the randomness. We can also use that signature for various things. For example, essentially, each round outputs the secret key multiplied by an identity. And that identity increments by 1 every time. So we have this well-known sequence of identities, with each identity being a round of the protocol. Now, in our native randomness beacon, that would be block numbers. You'd encrypt for a future block number. And when that block number is produced, we produce a signature that lets you decrypt a message encrypted for that block. In the DRAND perspective, instead of encrypting for a block, you encrypt for a DRAND round number. So essentially, it's an identity-based encryption. It is a cryptographic scheme using BLS signatures And yeah, it's essentially IBE with a symmetric cipher over the top of it.
Yeah,
Hopefully.
something interesting, William, about the time lock encryption is that, as Juan point out, is that we are going beyond the interactive nature of a lot of protocols to being non-interactive. So because of the time lock encryption capabilities, someone can just think about something they want to encrypt for a certain amount of blocks. And only when certain block is reached in the future is where everything will be revealed. And just think about a payload where you can just go in from having just a cipher test because you want to keep something secret, or just something more sophisticated like a contract call or a string call or whatever you can imagine in the future, which make it very suitable for a lot of interesting use cases where just imagination is your limit.
Yeah, one really interesting use case I love to go back to is non-interactive or asynchronous non-interactive multi-party protocols. So that's a kind of a mouthful, but essentially with time lock, you can start to think of protocols where you and I can coordinate our actions in the same protocol, but we never have to communicate. We never have to know who each other are. We never have to reveal any information beforehand, but we can still participate and complete the same protocol, which is really, really interesting to me. Especially like take, for example, in the context of Web3 gaming, you can start to build games where you're competing with people, but you don't have to specifically connect with them or know anything about them, but you can still compete for the same resources, for example. So you can kind of basically like one way to think about it is like simultaneous transactions. So like in today's world, if you and I want to do something at the same time on chain, that's going to be really hard. We need a ton of communication. We have to get really lucky too, which is pretty much impossible. But with time lock encryption, we can actually do that really easily if you basically the scheduled transactions for approach that we've already done, which is I think there are a lot of really interesting implications there, especially in terms of say like trustless protocols where you want to do a trustless asset swap between two people. With I want to make sure you send me the asset, you want to make sure I send you the asset. But we don't want to have to send our assets to any third party. How do we do that? Actually, time lock encryption makes it really easy.
Yeah, that's true.
And one more application, I believe that I read in your documentation is with keyless wallets or something like that, and that's quite interesting from a user experience point of view, because that's one of the things that's really keeping regular people out of crypto. Is there a little bit that you can talk about in that direction?
Yeah. So last October, right?
Yeah,
Last
that's
October
October.
was the One Block Hackathon. So for that, we actually implemented this really interesting scheme that we discovered called Hours of Horus. So Hours of Horus came out like 2021, completely theoretical based on witness encryption. And in the paper, they're basically saying like, this is interesting, but we can't practically implement it yet. Well, it looks like we can. Luckily, so we implemented this scheme, which is really interesting. It essentially uses the approach is to take a short password and to essentially use an OTP code generator to generate future OTP codes that are encrypted for future round numbers of the beacon protocol. So essentially the way it works is instead of authorizing calls and transactions by checking a signature, this approach is actually going to send the OTP code. The runtime decrypts the time lock encrypted one. There's some other really cool stuff that goes on. And essentially it allows users to use a short password instead of a long mnemonic or giant key. So there still is a password. There has to be something, but it makes it much simpler without sacrificing any security or economic. The economic impact is very minimal as well. So. And it's completely non-custodial, which is also a really interesting aspect of it. You kind of get the best of both worlds of the custodial wallet and non-custodial. Or by custodial, I mean the simplicity of it, and non-custodial is in the ownership. You don't need to manage your mnemonic or phrase or store your secret key anywhere. It's just this short string that you can remember.
Yeah, one of the things that we consider when decided to implement Murmur, which is the name that we give to this wallet. Of course, it's just at experimentation stage at the moment because it was we wanted to showcase the use of time lock encryption on how powerful it is for kind of different use cases. So we decided to go with this uh, keyless crypto wallet idea, which because we know that onboarding users and kind of removing friction from so we can allow users to use the protocols and tools within the Web3 ecosystem is kind of a very important goal for everyone involved here. So we wanted to kind of introduce something that we think that will have potential because once we have our product, our parachain on Polkadot, this will open the door to build not only Kilos crypto wallet, but other interesting features that rely on time lock encryption. So yeah, that's very exciting.
And something else I forgot to mention before, with the hackathon, we actually delivered integrations of the wallet into Twitch and Discord, as well as its own native application, which was a really fun experiment. We were actually able to go to Twitch, create a wallet, get some tokens from a faucet, send it to a wallet created in Discord, send it back, and a lot of like really interesting
Yeah, it was very
applications with
interesting.
it.
So yeah, there's a lot of interesting, I guess, future applications, if I put it that way. But if I bring it back to this year, you're setting up to launch a parachain on Polkadot, and actually, you're quite a small team, right? Only 4 people, and so I feel like it's quite an undertaking to, create a new parachain, launch it, monitor it, and then build on top. I understand it's going to have interconnections to many other chains. Talk a little bit about, I guess, is it challenging? Is it difficult to create a chain and bring it into existence? What were the hardest parts, or what were the parts that were less difficult than you thought?
Okay, I can talk about that a little bit.
Yeah.
I guess difficult depends on how you take it, what you know, what you don't know. I think for what we learn on PBA, that helped us a lot to understand how everything works together. Also, my experience working at Parity helped me a lot. So I think that the most challenging thing is probably the lack of documentation as a developer. I think it's a lot of trying to find information or trying to get your way around information that is not there. So I know that there's a lot of efforts to build documentation around Substrate and how to deploy a parachain, and there are things out there. Sometimes it's difficult to find it. Sometimes it's not even there. But other than that, I think that if you want to build something, if you really want it, and if we have a good team, I don't think it's something impossible. I mean, it is reachable for sure.
Yeah, totally. I want to add some sense to that, and it is the fact that our team, yeah, we're a small team, but we have a great combination of skill set. So where Tony and Coleman, they have this background in mathematics and physics that really add a lot of value, and cryptography that really add a lot of value to the product, which means that we can kind of introduce these sophisticated protocols and ideas within the product that we are building. Juan and myself, we have a lot of experience in software development, entrepreneurship, and business that have helped us also in terms of how to kind of keep it narrow, the focus, kind of be very strategic in terms of how to approach different milestones and how to where to focus our energy and how to approach the effort. So I think there is a combination of things. we are a small team, but I think that we have experience and the skill to do it. And definitely the PBA education that we got through I mean, I think that's 100% something that reduce a lot the learning curve and our process and learning process. Yeah, so I think that's particularly for me. I think we all had talked about all of this. It's been very, very, very important for making sure that we understand what we're actually doing in this project.
And I guess not only so the Polkadot ecosystem, right? The PBA brought you together, and then you came up with this idea during your cohort, and you went off to build it afterwards. But then you were funded by the Decentralized Futures. So can you tell a little bit about, I guess, how you brought the company to life, right? Where did funding come from? How did you come to a good working cadence? And how did you actually manage becoming a group, a good team?
Yes, I can take that one. So we actually initially we didn't know anything about randomness. We wanted to build a DKG chain.
Secret manager, right? Oh yeah.
Yeah, it's kind of like the lit protocol, so a distributed key generation chain. So our initial proposal was for that, not for randomness beacon at all. And then you can actually look at that proposal. The initial discussion is pretty interesting. It kind of transforms. We start from this DKG, and some of the authors of the paper were in the chat. Actually, I was like, oh wow, this is a little intimidating. But then we were talking to Jeff Burgess, Web3 Foundation crypto guy. And he was the one who kind of recommended we should start looking down this route, look into like the threshold BLS signatures using a DLEQ proof for verification instead of the pairing for more efficient on-chain verification. And that's what our native beacon is going to use, DLEQ proofs using his aggregatable BLS signature scheme versus just BLS signatures. So that's really what got us started. And that first proposal is just Carlos and myself, actually. So the things there, initially we were a bit disorganized, to be honest. Like the code was a little, not all over the place, but it wasn't super formalized and normalized. It was still good code, solid code, but there's some things that weren't perfect. It wasn't production ready by any means. So then the Decentralized Futures program came around, and we actually started with a second grant proposal. And they said, no, we don't want to do this. Do this instead. So they basically pushed us into the program. I think we were one of the first teams. We're kind of like a guinea pig a little bit, I think.
Yeah.
Which was a fun experience. But
we actually had to make a different decision, a hard decision, right, Tony? Because I recall when we were applying to the centralized future that we wanted to make it to be more ambitious. So we kind of make a proposal with a longer scope, so to get more runway and kind of extend the possibilities to create the network. But we got kind of a little bit of pushback, like if you want the money now, you probably want to go for a lower amount. Otherwise, you will have to wait. And we were in this situation where we really needed money because we were kind of trying to make it work with our own resources and bootstrapping everything. So we decided like, okay, let's take it the short path initially so we can secure. So those are kind of business decision and kind of how we can make things work. So we can keep building it if we don't know, we have some uncertainty in the horizon.
Yeah, well,
let me jump in. Let me jump in because actually time flies, and we're near the end of our session. There's a few questions that came in on the chat, and I don't think that we're going to have time to cover, but I'm going to ask you guys to kind of check up and maybe respond async a little bit later. But I'd love to give each of you just a little chance to, say one last thing. Maybe it's advice to future PBA students or people that want to start their own company project in the ecosystem, or what you're excited about that's coming up next.
I guess, my quick sign-off message. I guess message to future students. The really interesting things and the important things are not going to be easy. It's going to be difficult to learn those things potentially. There's always going to be a learning curve. So just don't give up if something seems hard or you're struggling. Like, just keep trying. Eventually, hopefully you get it. If you don't get it, ask for help. But just don't. Basically, just keep trying. That is my
PBA
my
is
final.
definitely PBA is definitely not easy. It's hard stuff, but it definitely pays off. It's definitely rewarding. So I encourage everybody who wants to do it to go and do it.
Definitely. I would say that I would complement the advice of my co-founders, saying that I would definitely encourage people to take the PBA if they have the chance to, because I think that this is going to be good for you to discover if this is going to be a passion for you. It is something that resonates with you, and also will reduce a lot the learning curve in your journey. So that's one step that I think that makes sense. Then you can either decide if you want to join a team or if you want to build your own project. I found out that Web3 Foundation and a lot of programs within the ecosystem are there, always available for people get started. And I think that there is no friction that happens to us as long as you have a clear idea and demonstrate that you can kind of want to work on that and have a solution in mind of what you want to do as an initial idea, what you want to build. I think that the doors are open for that. But I think that my advice is do whatever you think is natural to do. You can either work for a company or you can either build something, but definitely you feel excited about once you get the academy. I think that definitely you should go and through this journey, which is going to be hard, but I think that it's going to be very grateful because we are contributing to create fair protocols for the world. So we're excited about that journey.
And on that note, message from the PBA. Actually, the next PBA 5 is coming up very soon. The application process finishes, or the initial application deadline is the end of this month, January 29th. So be sure to take a look at the webpage, Polkadot.academy. Send in your application if you're interested. There's 2 tracks. One of them is for Substrate or kind of blockchain development, and the other one is for dApps, for decentralized applications. So yeah, take a look at the webpage, submit your application. Otherwise, thank you very much. It was great to meet all of you from Ideal Labs. Ideal Labs is a shining example of, a team that, came into Polkadot because of the PBA, met there, came up with a new service. It's very complex. It's very advanced. It brings something very new to the Polkadot ecosystem, right? Low cost, higher frequency randomness. And you guys are have since graduating are building a parachain and so many more services and new capabilities that are going to be released on top of it. So thank you very much for the conversation today, and yeah, we'll see you around in the ecosystem.